All right, so Vanessa, these are yours, right? Yeah. You got 8, right? You just need me to go over. Oh, it was just 9? Yeah. Okay. All right, so 9 says find the standard form of the equation of the hyperbola with the given characteristics. Vertices at 0, plus and minus 3, and passes through negative 5, 4. So if it's got vertices at 0, plus and minus 3, we know it's vertical. We know the center's at 0, 0. And we know A is 3. So I'd get x squared, I'd get y squared minus x squared equals 1, and this would be over A squared, and this would be over B squared. So I have y squared over 9 minus x squared over B squared equals 1. Then this is my x and this is my y. So 4 squared over 9 minus negative 5 squared over B squared equals 1. 16 over 9 minus, this would be 25 over B squared equals 1. Subtract the 16 ninths, so 9 ninths minus 16 ninths, negative 25 over B squared equals, and that's negative 7 ninths. Cross multiply, so negative 25 times 9, negative 7 B squared. This is 45, 225, negative 225. Divide both sides by negative 7. B squared is 225 over 7. And then that goes into your equation. So y squared over 9 minus x squared over 225 over 7 equals 1.
Oh, I accidentally put the b squared under the y.
Gotcha. Okay. Okay, this one, Sophia's. So the first one, which is the one a lot of you guys had questions on, like 8. So the foci is plus and minus 10. So I went right 10, left 10. That tells me it's horizontal. So x squared minus y squared. It tells me the center is 0, 0. And it tells me C is 10. Then the asymptotes are 3 over 4. It's horizontal, so that's B over A. So B should be 3 and A should be 4. But I said this yesterday. Remember, you had to check to see if that was reduced. So in order for it to work, C squared has to equal A squared plus B squared. And 3 squared plus 4 squared is 9 plus 16. That's 25. It doesn't equal 100, which would have been the C squared. So that's how you know it is reduced. And it only can happen with so many letters, so many numbers, and this is why you kind of want to know your triples, because if it's 3, 4, the C has to be 5. If the C is 10, and this is a whole number, then it has to be 6, 8, 10.
I think that's why I didn't have to.
Yeah. So then I know that the 3 was actually multiplied by 2, and the 4 was actually multiplied by 2, and that makes B 6 and A 8. And then you know where to go from there?
Yeah.
Okay.
So the x squared over 64
Yep.
minus y squared over 36 equals 1.
Good. And then 9, so this is just like Vanessa's. This time you're going up and down 3. So I still know that my center's at 0, 0. This time it's vertical, so it's y squared minus x squared. And my A is 3. So I have y squared over 3 squared, which is 9, minus x squared over B squared equals 1. I don't know B, but I know an X and a Y. So if I plug those in, I would get the Y, the Y is 5 over 9, minus the X is negative 3 over B squared equals 1. So it's 25 over 9 minus 9 over B squared equals 1. subtract the 25 over 9, negative 9 over b squared equals, this would be 9 ninths, negative 16 ninths. Cross multiply and I get negative 81 equals negative 16b squared. Divide both sides by negative 16. B squared is 81 over 16. So then my equation is y squared over 9 minus x squared over 81 over 16 equals 1. Good? Yeah, okay, and then pull it in, yeah. Oh, it's the same thing. So did you hear what we were talking about? It's because it's not reduced. Oh, no, it is. This one's fine. Sorry, just kidding. It's not the same thing. So this time, foci up and down would be my covertices. Right and left is my foci, so positive 5, negative 5. This tells me it's horizontal. You just switched your letters.
Oh.
That's all.
Oh.
Because it's horizontal, 4 is the A, 3 is the B. And by letters, I mean numbers on the bottom. That's all. You just switched them. Does that make sense?
Mm-hmm.
Yeah, okay.
So is it A over B or B over A?
If it's horizontal, it's B over A. If it's vertical, it's A over B. All right, then Audrey. So this was from the day before, right? So we did the equations the day before. The first thing you would know is that the y comes first, so this is vertical. My center is negative 1, 1. Opposite of what follows x, opposite of what follows y. My a squared is 1/4, so a is 1/2. My b squared is 1/9, so b is 1/3. So when I go from my center,
So you just like leave the fractions there, you don't do anything with them?
right,
Okay.
they just make your numbers yuckier, but you don't have to move them.
Because when I, like, at first, like, I thought, like, I didn't want to put anything in, because I had thought, like, I tried working it out on paper, and, like, I got something funky, because I tried to, like, multiply, like, remember, it was, I think it was, like, a couple lessons ago, when, like, you multiply, like, by 9, or, like, by 3. Or, do you know what I'm talking about?
To get rid of everything?
Yeah.
Yeah, you just can't, because you can't get rid of the 1. That 1 on the other side has to stay there in standard form.
Okay.
Yeah.
That's what I tried doing when I was,
You can't,
I
yeah.
got really confused, and I didn't get what I should have got.
So from there, like, there's your center, right, negative 1, 1, and then it's vertical, so I'm gonna go up and down the A. So the A is only a half, so I go up a half and down a half, and that means that those are my vertices. They'd be negative 1, and then the 1 plus the 1/2, so 1.5, and then the negative 1 and the 1 minus the 1/2, so just 1/2. Those would be my vertices. Then I'm gonna go right and left 1/3, because that's my covertices. So the covertices, I'm going left another 1/3, so I go negative 1 and 1/3, and 1, and I go 1/3 less, so it'd be 2/3, negative 2/3, and positive 1. And then that's my little box, right? And then your asymptotes that cross through these, and then it's vertical, so it was up like this, and down like that. And then you had to find C, so C squared equals A squared plus B squared, so 1/2 squared plus 1/3 squared, which is 1/4 plus 1/9. That you have to change to have a like denominator, so this becomes 4/36, and this becomes 9/36, or 13/36. And then you have to square root it. Square root of 13 stays a square root of 13, but the square root of 6 goes to 6. So then from there, you want to add that to the center, to the y, because the foci would fall in here. So my x stays as negative 1, but then my center, which was 1, the y part of it, gets added and subtracted the square root of 13 over 6. And that's where those other values come from. And then the asymptotes, it's vertical, so it's y equals k plus and minus. It would be a over b because it's vertical, x minus h. So this is k is your positive 1, plus and minus. The a is 1/2 and the b is 1/3. X minus a negative 1 becomes plus 1. And then this has to get simplified. So 1/2 divided by 1/3 is the same thing as 1/2 times 3 over 1 or 3 over 2. 1 plus and minus 3 over 2, x plus 1 should have been the asymptotes. So it just gets really messy because of the fractions in the bottom.
Okay.
Yeah.
Thank you.
You're welcome. Okay, Madison, here's your number 9. So it says find the standard form if it has a vertices at 0 plus or minus 2 passes through point negative 4, 3. So we're going to go up and down 2 for the vertices, which tells me this is vertical, which means it's a y squared minus an x squared. It tells me that the center is at 0, 0 because it's halfway between. And it tells me that a is 2. So I know the a squared goes under the y squared and the x squared gets the b squared. So I have y squared over 4 minus x squared over b squared equals 1 so far. Then here's my coordinate point. This is my x and this is my y. So y would be 3 squared over 4 minus the x is negative 4 squared over b squared equals 1. Square that 3, you get 9 over 4 minus, this would be 16 over b squared equals 1. You have to subtract the 9/4 from both sides, and I get negative 16 over b squared equals 1 becomes 4 over 4, so it has the like denominator, and that's negative 5/4. Cross multiply, negative 16 times 4 equals negative 5b squared. Negative 64 equals negative 5b squared. Divide both sides by negative 5, and b squared is 64 over 5. Then I have to go back up to the equation that I had, which is here. The only unknown I had was the b squared, which I now know. So y squared over the a squared, which was 4, minus x squared over the b squared, which was 64 over 5, equals 1. And there's the standard form of the equation. Maddie, this one's yours. So where'd yours go? Sorry. So let's work through these. So yesterday we did one with the, yeah. Okay, so again, I just said that that should have been switched. So 0 plus and minus 9 is the y-intercept. It doesn't make sense the other way around. Okay, if I graph it, this means I'm going up 9 and down 9. As my y-intercept. So remember we said yesterday that they say y-intercepts, but really they mean something else, right? In this case, if my foci is 0 plus or minus 15.
The number was 3.
It was 3, yeah, but that's way too big of a group of us. I mean, it can have, but a span in between. But that was yesterday's. I copied part of yesterday's that we did. We did plus or minus 3 on yesterday's. The difference between the foci is now on that vertical axis, so I know that that y-intercept is really a what? A vertice. So I know that this is vertical. I know that my center is at 0, 0, halfway between either of those points. I know that my A is 9, and I know that my C is 15. So now the only other thing I need is B. C squared equals A squared minus B squared. 15 squared equals 9 squared minus B squared, 225, 81, 144, negative B squared, plus, this is plus, B is the other one. Holy moly, on a roll today. Did I do that part right? I wrote it wrong. It should have been, this should be, because I didn't have I had a plus there. Minus 81, yeah, 144, and then the B is 12. So now when you plug it into the equation, it's vertical, which means the y comes first. Y squared over a squared, a was 9, so a squared is 81. Minus x squared over b squared, b is 12, so b squared is 144, equals 1. So I will tell you that the benefit of not having a hyperbola tomorrow is you can solely focus on the ellipse formulas, because those I think are the ones that we kind of cross over. But next Friday, you're going to get them both on the same one. So you definitely want to either create yourself a reference sheet, which we're going to try to work on to get together today, or be really, really careful. Again, today's and tomorrow just has the ellipse. So it should be a little bit easier. But then next Friday's going to have both. Nate, you got to yell at me when I make a mistake because you're faster than me and I don't stop and read. He caught that mistake. Just yell. Just be like some kids love to catch teachers when they have mistakes, don't they? Like feel smarter than your teacher for a moment. I am not the type of person that gets upset if you catch my mistake. It helps me out, so. All right, the next one. Vertices at plus and minus 10, 0. Asymptotes at negative 5x and positive 5x. So first thing I know is that I'm going right and left the 10, which tells me this is what kind of hyperbola? Horizontal. What else do I know? Center at 0, 0. What else do I know? Good. A equals 10. Then it says asymptotes are at positive 5x and negative 5x. So my negative 5x or positive 5x equals, it's horizontal, so this is the b over a x scenario. So 5 equals b over 10, because a is 10. Cross multiply and I get b is 50. With me so far? Yeah? If you want to write it out as 5 over 1, you can. 5 over 1 equals b over a, and then we get 5 over 1 equals b over 10, and then you can cross multiply and you get b is 50. Either way, you get it. So then when I go to put this into an equation, it's horizontal, so it's x squared minus y squared. The x gets the a, 10 squared would be 100, and the y squared gets the b, 50 squared is 2,500 equals 1. So big numbers, but they're still hopefully relatively easy. Okay, last one. Vertices, 0, negative 5, and 0, positive 5. So now we're going up and down, which means this is what? Vertical. What else do we know? Center 0, 0. Good. A is 5. Then it says it passes through, so this is my xy scenario, right? So I already know that it's y squared minus x squared because it's vertical. A squared would be 25, and then this would be over b squared equals 1. That's all the stuff I already know. Now I plug in these points. So 10 squared over 25 minus 3 squared over b squared equals 1. And then 100 over 25 minus 9 over b squared equals 1. We can actually simplify this time. This would be 4 minus 9 over b squared equals 1. Subtract the 4. And I get negative 9 over b squared equals negative 3. We can still cross multiply, so I can put this over 1 if I want to cross multiply, and I get negative 9 equals negative 3b squared. Divide both sides by negative 3, and b squared is 3.
Wait, how did you, I don't understand what you did for the last step.
From what color?
Like the purple there.
From this one here? Or up here? Which one?
The bottom.
The bottom one?
Yeah.
So once from here, like I put negative 3 over 1 so I could cross multiply, and then I cross multiplied. So negative 9 times 1, negative 3 times b squared, and then I divided both sides by negative 3. This is negative 3. So then b squared is 3. And then I go back up. Y squared over 25 minus x squared over 3 equals 1. Questions on any of the hyperbolas before we put them on snooze? We'll come back to them on Monday.
Are we learning anything else for the test?
So Monday and Tuesday, it's basically completing the square to get them into standard form. Hyperbolas, ellipses, and parabolas. So they're all different kinds of equations mixed together. You complete the square, and once you complete the square, you'll either get a parabola, an ellipse, or a hyperbola, and then you go from there. So the complete the square, we've already done, we just haven't put the two together. We have to complete the square, sometimes we have to complete the square twice for the x and the y. But then you put it back into the standard form, and then the good thing is we review. So we'll review if once it's in standard form, what are we doing with the ellipse, what are we doing with the parabola, and what are we doing with the, so we just add on the complete the square part of it. Yep, and then that's it for your test. So my advice is to create yourself a reference sheet if you haven't done so already, okay? I would even recommend, I'm gonna do this and I'm gonna let you take a picture at the end if you want, but I recommend you writing it, right? We remember things by writing it out, so it would be helpful just to write it out, okay? It's also helping you know what you know and don't know already. So I'm going to start with the parabolas, and then I'm going to go to the ellipses, and then I'll zoom out on this at the end if you want to take a picture. But I'm going to go one at a time. So this is what's on your quiz tomorrow. So both of them are going to have where you get the equation, and you have to find the information from the equation. Excuse me. And they're both going to have, here's information, get the equation. So with the parabolas, we start with two standard form equations, okay? One is y minus k squared equals 4px minus h. And this is a horizontal parabola. So it faces to the right or to the left. If it's a positive, it faces right. If it's a negative, it faces left. The second is x minus h squared equals 4py minus k. So the h always goes with the x, the k always goes with the y. And this points down if it's negative or up if it's positive. Sometimes that x and the h and k are 0, 0. And so it would be y squared equals 4px minus x, sorry. And it would be x squared equals 4py. So that's if my vertex is 0, 0. It would be y squared equals 4px or x squared equals 4py. So if my vertex is 0, 0, that's what it would look like.
I know when to use the line at x squared. If it's like vertical, you use the y squared.
Correct. There can be nothing on the front of the squared terms. Not a negative, not a number, nothing can be on the front of the squared terms. If there is, we move it to the other side. So if that said 2 parentheses y minus blah, 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 we would divide both sides by 2. If it said negative on the front of the parentheses, we would divide both sides or multiply both sides by a negative. You have to have nothing on the side with the squared. And they will trick you and they will put the squared on the other side. So be careful, okay? Like it could say 4x equals y squared. That's still a y squared. And if you want to rearrange it, you can. You just got to be really careful. All right, so for these, the vertex is hk. P is the distance between the vertex and the focus and the vertex and the directrix. So 4p is what's on the actual equation. We set 4p equal to whatever's next to the x or next to the y, whichever's not squared. We solve for p, and that's the distance between the vertex and the focus, and also the vertex and the directrix. So remember, we're either going to count up or down the p to get the vertical parabola, or we're going to count right or left the p to get the horizontal parabola.
For the y squared equals 4px, is that one the vertical and the horizontal?
That's vertical. Yep. So this would be up or down. No. That's not vertical. Sorry. That's horizontal. We used to just do x squareds, right? And x squareds are always up or down. The other thing is that the focus is a coordinate point and the directrix is a line. If the parabola opens up or down, the directrix is going to be a y equals. If the directrix opens right or left, the directrix is going to be an x equals. The quiz is also going to ask you for your axis of symmetry. So it's been a while since we did that. That goes back to the parabola. So the axis of symmetry, if it's vertical, so the x is squared, it is an x equals the h, because it's going to run through the vertex. If it's a y squared, so it opens left or right, it's a y equals the k.
When you did the p equals the distance between the vertex, like what do you know which one to do? Like,
Which direction to go?
no, like the vertex plus focus.
It's both. So it's the distance between the vertex and the focus, and it's the distance between the vertex and the directrix. So we're going to find the vertex, and then we got to figure out, is our parabola up or down, or right or left? If it points, let's just say it points up. We count up the p, that's the focus. We count down the p, that's the directrix.
Okay.
If it turns to the right, we count right the p, that's the focus. We go left, the directrix. So remember, it never crosses through the directrix. It always goes the opposite way. It goes around the focus.
I have a question.
Yeah.
The axis of symmetry, if we got like if it was a negative, could it be a negative?
Yeah. The vertex, you mean?
For the axis of symmetry.
With this, so that goes back to the coordinate of your vertex, right? So like if I had, let's say I have an equation that says y minus 2 squared equals 8x plus 1. Let's say this is my equation, right?
So it would have to be plus an h or plus a k to give you a negative axis of symmetry.
Correct. So my vertex here is negative 1, 2, right? This is a parabola that points to the right because the y is squared and the 4p is positive. So this points to the right. So, and the 4p equals 8, so p equals 2. So when I go to graph this, I'd go left 1 and up 2. That's my vertex. I'm going to point it to the right because I said it's a positive 4p but a y squared. I count to the right 2 places to get my focus. I count to the left 2 places to get my directrix. It's a negative, what do I go from negative 1 to negative 3? And my axis of symmetry runs this way through my vertex. So it's a y equals 2 because it's the k coordinate of my vertex.
So are these like opposite from hyperbolas? Because if when in
The y comes first, it's vertical. Yeah,
Okay.
yeah. I always think like when I like have that moment where I'm like, huh, like I always think when we learn parabolas first, we learn them as functions. So it's an f of x equals an x squared. The y was never squared before. And those always went up or down. Then we started to bring in the conics, and that's when we turn them right or left. Now the y can be squared. But when we started with things, they were called quadratic functions. Our y could not be squared. Does that make sense? So that helps me remember which one's which. But yes, it is technically the opposite of the hyperbola. Okay, so now I'm going to do ellipses.
Okay, so that is horizontal, that one?
So that one is technically a horizontal, yeah, that's a horizontal parabola. All right, then ellipses. Okay, I'll start where the center's at 0, 0.
But I have one more question about the problem.
Okay. Okay, so if the center's at 0, 0, then my ellipse equation is x squared over a squared plus y squared over b squared equals 1. And this is horizontal. Or if it's vertical, it's y squared over a squared plus x squared over b squared equals 1. Now the order is not what's important here, remember. It's what the larger denominator is. So if the larger number is under the x, it's horizontal. If the larger number is under the y, it's vertical.
This Professor, how do you distinguish when you put the plus in the equation and the minus in the equation?
You mean in the original one, the ellipse is a plus, and the hyperbola is the minus? Is that what you mean?
Oh, yeah. Okay.
Yeah. But remember, the c squared relationship's the opposite. The c squared equals a squared minus b squared. So the sign on the CAB equation is the opposite of the standard form.
Wait, what?
This sign is minus for an ellipse, and an ellipse is plus. And it's the reverse for a hyperbola. Ooh, that would have been bad if that was open. All right, A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. C is the distance from the center to the foci.
Doesn't the order not matter on these ones? Or
Correct. Yeah, because it's plus in my initial standard equation, the order does not matter.
wait, I don't get what the question.
The order on these, like if this is switched, if it's an x squared over b squared plus y squared over a squared, it's the same equation. The order doesn't matter.
Oh.
What determines what kind it is what the bigger number's under. Bigger numbers under the x, horizontal. Bigger numbers under the y, vertical. And then if my center is not at 0, 0, so it's shifted, it's at HK, the only thing that changes is the top of my equations. It's still horizontal if it's x minus h squared over a squared, so the x still has to be over the larger number. Y minus k squared over the b squared equals 1. And vertical would be y minus k squared over a squared plus x minus h squared over b squared equals 1. Again, order not important. What's important is which letter the bigger number is under. This time the only thing that changes is that the center is HK. Everything else is still the same.
Does x always go with h and y?
Yep.
Okay.
Always, always, always. Doesn't matter if it's a circle, doesn't matter if it's a parabola, doesn't matter if it's a ellipse, doesn't matter if it's a hyperbola. Yep. X always goes with H, Y, K always goes with Y. Yep. And then the only other thing that we had in this section was when we started to do our equations, we were given the major and the minor length, right? So 2A equals the major axis and 2B equals the minor axis. So that helped us figure out some of our information when we were finding the equations.
I know this is not to do with what we're taking tomorrow, but they had a different name for the hyperbola.
It's transverse and conjugate.
Okay.
Yeah. But yeah, but you don't have to worry about that for tomorrow. Next Friday, yes? So next Friday we'll do the same thing. We'll add on hyperbolas. We'll make the reference sheet with those two. Okay, so this is basically what you need to know. It's teeny tiny when you zoom it out like that. I would strongly recommend that obviously you create one of these on your own. I would not keep it, I mean, if you want to do an example of each of these, you want to add a couple of notes on here, that's fine. But I would not do more than 1 page of notes. 1 page front back, that's fine. And don't make it like size 8 font. You're never going to be able to find it, okay? I would try to keep it as simplified as you can. Like I said, if you also want to do your review on the back, I don't care. If you want to do an example of each one, I don't care what you use. I would just say, don't overwhelm yourself with notes and go digging to the point that you don't have time to finish.
Are we taking this on paper?
You guys are going to get the questions from Canvas, but then I'm going to print you an answer sheet. Yeah. Oh, folks from home, I'm going to post the answer sheet on the quiz review itself. Hi. I'm going to ask that you print that answer sheet. If you don't have a printer, then please get a white piece of paper and make it look like the answer sheet. It's pretty simple. It's just like 4 questions with a coordinate grid and then the little blanks that say vertex and all that good stuff. But it will make it so much easier. And then you're literally just going to get your questions from Canvas. You're not going to answer anything on the Canvas quiz. You're going to answer everything on the quiz, on the paper. And then you're going to submit that paper to the separate assignment. So just to be clear, I'm only grading that paper. I'm not going to grade anything you type into Canvas, so don't waste the time. Last time we did this, somebody typed in all the answers in Canvas for the center, not center, but that kind of answer. I'm not going to grade that stuff, so don't waste your time doing that. Go straight to your answer sheet and answer it on the answer sheet.
Can we go over the graphs for the ellipses?
Sure. Yeah. So if you want to center, you want to shift it center?
Yeah.
Yeah. So let's do one example where we've got x minus 3 squared over, give me a perfect square. 25. Give me another perfect square. 49. That was creepy because that's what I was thinking of, but this is weird. Okay. All right. Maybe that means good vibes will come to tomorrow, Vanessa. Maybe you can get into my brain and I can get into yours. Okay. So, so what do we know about this ellipse already?
Horizontal.
It's horizontal. Bigger number? No.
No, it's vertical.
It's vertical. Bigger numbers under
The Y.
the y. This is vertical.
Wait, but when we made the parabolas, wasn't that the x squared was the vertical one though? Right?
Correct. But they're both squared in an ellipse.
So for the parabolas, everyone is squared.
Correct. For an ellipse, it's whichever one has the bigger denominator. For a hyperbola, it's whichever one comes first. So
Like
3 different cases.
parabolas.
For parabolas, it's based on which one's squared. And there's only one variable squared in a parabola. But in an ellipse and a hyperbola, there's 2. Does that make sense?
When we did the parabola one, the x squared was.
It's vertical.
Opposite.
It's opposite.
Oh, that's right.
Yeah, it's opposite, yeah. Okay, so this is vertical, right? The center is what?
3 negative 2.
3 negative 2. My a squared is what? 49. So a is 7. The b squared is 25. So b is 5. So I would draw out. Today's the day I don't want it to ring early, Mr. Saxton. I would count 1, 2, 3, down 2. Here's my center. The denominator square root goes with how far you're moving on that axis, right? So because the 7 is under the y and it's vertical, I would count up 7. 1, 2, 3, 4, 5, 6, 7. Count down 7. 1, 2, 3, 4, 5, 6, 7. So the y change there, not the x. I take my center. I go up and down 7. So 3, negative 9, and 3, positive 5, which would be exact on your coordinate grid too.
This probably isn't gonna make any sense, but it's like an it's like you do the opposite that you would do for a hyperbola.
Not
Most
the
of it.
opposite. Not really, because the A and the B is still the same. The difference is the shape at the end.
The shape at the end, but like for like the a squared, it's now minus b squared equals c squared.
Yes, that's opposite. So
And
C
then, like,
squared.
instead of it being a squared first, it's whichever's bigger,
Yep.
and then
So this would be 2 root 6. That part, yes, you're right.
For the
I
photos
think-
tomorrow, are they gonna be like square roots?
probably. But I
Perfect
think-
squares? No. So Madeline just asked a good question and it piggybacks off of what we just did. Will the foci be a perfect square on tomorrow's? No. So I would take that and I would estimate it if I was graphing it to be a little bit less than 5. So 1, 2, 3, 4, 5, like here. 1, 2, 3, 4, 5 here. On the graph, you're going to estimate. And then when I give those exact points, that's adding and subtracting again to the y. So it'd be 3, -2, plus and minus 2 root 6. Does that answer your question? Yeah. All right, the quiz review, I did publish it, right? Yeah. It's up there. I'll post the solutions and I will, Madison, do your number 9. I will also add the answer sheet onto the quiz review for the folks from home so you can get it printed. Bye, guys. Have a great day.
So if the bigger number